Thank you for hosting this. Thank you everybody for coming, and thank you in advance for comments. So my name is Gregory Warren, R. Warren. I have a PhD in biostatistics, and I am jumping out of my field to talk about how to get people faster internet, particularly in rural America. So in the United States alone, there are, according to the federal government, more than 100 million Americans who can't get access to fast internet, meaning they can't even buy it. Money's not the question. The question is actually having access. So that's the problem. People need the internet. This is an example of a circumstance where the internet would be really useful. All people in rural areas can't participate in this from home. They have to go somewhere where they can get internet access, and that's not ideal. So I have... It's upside down. Now that people can hear me, I have come up with a solution. A few years ago, I created a patent that allows you to send a whole lot more data through the same wireless connection that people are using now for their cell phones, et cetera, so that you can get higher data throughput, better noise and jamming resistance, but at the end of the day, you can get more data to more people cheaper. So here's an example. So the current technology for wireless internet access has distance limitations about 2.5 miles, a speed limitation at most 100 megabits per second, other limitations, et cetera. We can take that out to 10 miles, which is a 16 times larger area. We can take the speed up to 500 megabits per second. That speed number there is actually really important because you may know the federal government just passed an infrastructure bill, infrastructure law now, that puts $65 billion into bringing internet infrastructure to places like these rural areas. The problem is that even if you have the money, it's very expensive to bring internet to places that aren't close to the base stations. And this is a way of solving that problem. So, and I have no idea how long I've got since the timer isn't up. Okay, so our plan is, so I've developed and patented the core technology. Now I am in the process of building the prototype. And once the prototype is built, then I'm starting to look for partners to actually do field tests of this technology to demonstrate that it is real. The performance improvements are so dramatic that it's hard for people to believe that it can be real. So this is a real key step for me, is to actually get with people who can look at the results and actually see that they're real and not just a pie in the sky. And then our business model is that we look to launch into a small market. So in this case, small is the wireless internet providers for rural America. And then once we've established that and we've figured out all the kinks in a relatively simple market where both the transmitter and the receiver are owned by the same company and manufactured by the same company, then we expect to launch into a large market. We can take this and it can be applied to cell phones, satellite TV, military and first responder radios, et cetera. So this has a lot of legs to go. The trick is getting over this initial spot of having the idea, having proved it mathematically and in simulations, and now getting it into actual hardware. What we're looking for is two things. We're looking for connections with folks who would be in the position to work with us to do these tests, partners ideally. And the second thing is we're looking for some seed money to get us through the next couple of months so that we can build our prototype and get really in the game. And this is us and how to contact us.
Nice pitch, thank you. Greg, tell us a little more about your educational and professional background.
Okay, so I have a PhD in biostatistics. I also have an undergraduate degree that splits between computer science and statistics, and I've been playing with electronics since I was a kid.
So you're a Radio Shack guy.
Yes.
Yeah.
Yes. I spent a lot of time at Radio Shack, And I'm sort of circling back to my roots. I took a detour through high-performance computing and genomic data analysis, data science, and I'm sort of coming back around to the electronics now. And in fact, the patent idea here that I created, I think I was only able to do this because I would think about the problem differently than a standard electrical engineer does. I used the project name Sideways for this project because it was coming sideways at the problem. And that let me look and see something that other people hadn't seen, and use my mathematical skills that I got from a PhD in biostatistics, which is the mathematical discipline, to actually do the math behind it to prove that it would work.
Okay. So in broad terms, what does your patent cover?
Patent covers a new way of taking the data and converting it into signals. Basically, it allows you to use time offsets as a key, so that you can transmit the data for you using one key, and for the person sitting next to you with another key,
Okay.
and somebody else with another key, and those can actually be transmitted at the same time. Most of the wireless technologies that exist right now, either everybody you have to take all the bandwidth and split it into a little channel for everyone, or you have to split the time into a time chunk for everyone.
Mm-hmm.
This allows you to get around both those barriers and basically to be continuously streaming all the clients and all the along concurrently.
Okay, great, thank you. And you mentioned, I think his name was Tony, your CEO?
Yes, sir.
Is that the team?
That is the team at the moment. One of the things that we want to do with the money is to bring in an electrical engineer to actually help us build it.
Okay, okay. All right, so fascinating concept. I think, to me, the headline is 100 million people don't have access to high-speed internet. That's at least a third of the population, right?
Yep. And the piece that, again, I had my other presentation, I have this line that there's the $65 billion available to pay for internet.
Yep.
And this performance thing here, I miss coming back to this, is the current wireless internet access doesn't qualify for most of that money because it's too slow. It has to get over the 100 megabit per second limit to actually qualify for the full bucket of federal money. And so most wireless internet providers in rural areas, wireless is necessary because it's too expensive to run cables. Can't get access to that bucket of money because the speed limit is too low on the existing technology. So with this, they can get over that speed limit and suddenly have access to that full $65 billion plus.
Yep, yep. Okay, so something I think to expand on is kind of what are you thinking about from a go-to-market strategy? Do you envision being an end-use provider? Do you envision being a tag-on to an existing provider? Do you envision licensing the technology to a broadband carrier and being done with it? You should say a little bit more about that. The other thing is, I would project a longer-term plan. You said, and I think you were just speaking casually, but you said we need a little seed money to get us through the next few months. Well, you probably need, in reality, you need money to get you through the next few years.
Yes.
And the seed money is going to get you started, and that's hopefully going to lead to some follow-on financing, right?
Yes.
So I would lay out a little longer-term picture than the next few months. I think the connections thing is the right thing. You need connections to. You're not going to be a Verizon or an AT&T, and I don't think you have any aspirations to be.
Yeah, we do not want to be the actual company running it.
You kind of want to be the opposite, or you want to be with the Windstreams and those guys, right? And
actually, we want to be like Qualcomm. Qualcomm provides the technology,
Okay.
and then everybody else builds the equipment and manages the networks, et cetera.
perfect. Weave that analogy into your presentation. But I mean, to me, fascinating concept. Like so many technical concepts, and you did a good job of this. You avoided spending all your time explaining what the technology, how the technology works, and instead what problem it solves. So great job on that, and lever that extensively. Laura?
Hey, Greg.
Hello again.
My first question was about simulation. I think you touched on that. Have you worked on that?
Yes.
Okay, and successful?
Yes. So the The in computer simulations are demonstrating actually better results than I present, but I don't present them because they're too unbelievable, and because they don't take into account limitations of actual real-world systems, like moving from floating point to fixed point arithmetic in the transceivers, et cetera.
Okay. I wrote down patent, but you touched on that later. And I guess that, I mean, my biggest question that I would want to hear a little more about is, kind of barrier to entry, as far as the cost of really getting this up and going versus, how do you convince these companies to ditch what they have?
Yeah, that's where the building the actual prototype and partnering with someone to do some field tests is the key linchpin. So where I'm at right now, I've been told that until I have a prototype, we're unlikely to be able to get any funding because it's not real enough. So the goal is to get the prototype built and then to partner with a Verizon or a Windstream or another company to actually say, okay, we're going to put a receiver out here, we're going to put a transmitter on the tower, and we're actually going to test it out and see how it works in an actual real-world situation.
Okay. And then, as far as the presentation itself, I thought, this one versus the one that you did for us not too long ago, hands down, this was clearer and more concise, more understandable, more on my level, so to speak, than when you first came to us. As far as the slides are concerned, there's a fine line between too much, too little, but I think you did a good job cutting it down and actually referencing the ones that are a little bit, the chart and that kind of thing. You used them. It wasn't just up for visual, which can be distracting, if I'm sitting here feeling like I have to read all of that, but you highlighted what we really needed to look at. So I thought that was a good job. Maybe just a touch more projection. And I mean, all in all, it's been a while since since we talked the first time. So I think you've taken the notes and, done a good job. Yeah, I think that's all I have.
Okay.
Well done.
Good job.